here one phenomena is there which can be exhibited by sp3 hybridized carbon compounds. If any carbon is an asymmetric carbon means a carbon which is attached to 4 different groups, because each carbon can form 4 bonds. If these 4 bonds are satisfied by 4 different compounds, groups C, D. This is known as asymmetric carbon. For example, if you take alkyl halide, one alkyl halide which is having one methyl group, another hydrogen, and with C2H5, and one Cl is there. This carbon is said to be asymmetric carbon because here one side methyl group is substituted, in one valence is satisfied with hydrogen, and third valence is satisfied by ethyl group, and the fourth one is satisfied by chlorine. This carbon is said to be asymmetric carbon. Now it will shows this optical activity. What is meant by optical activity? Optical activity means any structure which is having that asymmetric carbon, and that carbon is said to be a chiral carbon, will exhibit these optical properties. What is the optical property? That means this isomer will have 2 structures. Another structure is the mirror image of this. Mirror image means if you keep one mirror here, you will get another image which we call it as mirror image. So CH3, this hydrogen, and C2H5. These two are 2 isomers. There is no difference. Same groups are attached here, but only difference is this figure is the mirror image of this figure. Chemically, they almost exhibit same properties, but only an optical property they differ. Optical property means if we pass a plane of polarized light, if one isomer rotate it into left side and other isomer will rotate into right side. The left side rotatory compound is said to be levorotatory. The isomer which rotate it in the right side is said to be dextrorotatory. L form and D form, we simply call it as L form and D form. Now what is plane of polarized light? We know that when a light ray is passing, if it is the path of the light ray, normal light ray, these electromagnetic radiations will distribute in all directions like this. This light is said to be a normal light. Plane of polarized light means if this is the light path, it rotates only this direction and this direction. This is said to be a plane of polarized light. We can get it from monochromatic lamp. We get this type of light, plane of light, polarized light, but this is normal light. From any light source you will get this type of radiation, and this is a special radiation emitted by monochromatic lamps. So if we pass this plane of polarized light, if one isomer, if this is the ray which we are passing, some compound will rotate it like this, and some compounds will rotate it like this. So this rotates to the right side and this rotates to the left side. So left side is L form, this is levorotatory, and this is D form, which we call it as a dextrorotatory. So if one isomer is levorotatory, its mirror image is said to be dextrorotatively. These two are superimposable. Superimposable means, suppose for example, if you take, this is my hand. The mirror image of this hand is this. So if I keep one mirror, this image is appear like this. Now if you keep this like this, it is not coincide. All fingers are not coinciding. If they are coincide, then it is said to be superimposable. If it is not coincide, it is said to be they are not superimposable. So the two optical isomers which are mirror image to each other and non-superimposable, such isomers are said to be enantiomers. Enantiomers. So they will ask in the examination like this, what are enantiomers? This is one question that you are going to get in the examination. Enantiomers. Enantiomers means two optically active isomers which are mirror image to each other and not superimposable. Such structures or such isomers are said to be enantiomers. Enantiomers. Now another question they may ask about racemic mixture. Racemic mixture. If any substance is containing 50% of levoform and 50% of dextroform, the optical rotation created by this 50% is neutralized by that 50%, so that the resultant ray is not rotate either in right side or left side. Such mixture is said to be racemic mixture. If levoform and dextroform of an isomer of a compound, if any optically active compound, both L form and D form are equally present, the 50% and 50%. So the rotation that was created by 50% of one isomer is neutralized by other 50% of other isomer. So the resultant ray will not have any rotation. That mixture is said to be racemic mixture. Racemic mixture means due to the presence of two different isomers, optically active isomers, L form and D form, in equal percentage in a mixture, though it is an optically active compound, it will not show optical activity due to the presence of two different isomers in equal proportions. That mixture is said to be racemic mixture. Then another important question we can face, the result of optical activity due to SN1 and SN2 mechanisms. So we know that this is an alkyl halide. It will undergo to nucleophilic substitution reaction. Here it is a secondary carbon, so there is possibility for SN1 mechanism and SN2 mechanism. There are chances for both the mechanisms. Now, if SN1 mechanism takes place, what is its influence on optical activity? If SN2 takes place, what is its influence? For example, if we take this compound now, if it is undergone to SN1 mechanism due to the influence of nucleophilic substitution reaction under the influence of nucleophile and proton of the solvent, this chlorine will be removed to form a carbocation with these compounds like this. This carbocation will attacked by a nucleophile. This nucleophile may attack from this side or from this side. If attack takes place in this direction, the resultant compound may appear like this. If attacking takes place like this direction, so there are two possibilities. These two are mirror images to each other. Now here, if it is L form, this is also L form, but this is D form. That means due to SN1 mechanism, same optical active compound may arise, or a different actical compounds may arise, or the mixture of the compounds. There is every possibility. If these two are formed in equal proportions, there is a probability, then a rhythmic mixture may form, or same stereoisomeric compound may form, that is retention of optical activity. So if SN1 mechanism takes place, the optical activity may retain. That means we call it as a retention of optical activity. Or if these two are formed in equal proportions, then optical activity will be 0, and this mixture is said to be racemic mixture. Suppose if SN2 mechanism takes place, what happens? In the same case, if SN2 mechanism takes place, the nucleophile will attack from this side, back side only, because this is optically positive and this is delta minus. So automatically OH minus or nucleophile will attack from this side, and it will form a transition complex which is unstable, and automatically this bond will be weakened and this bond will be strong. So resultant compound will be like this. That means exactly opposite compound is formed. This we call it as a Walden inversion. Due to SN2 mechanism, inversion of groups will take place because the nucleophile will attack the carbon in the opposite direction of the halide compound. So this was, if L form is take part into the reaction, resultant after SN2 mechanism will get a D form. If D form is take part into the reaction, we will get L form. That means due to SN2 mechanism, second optically active compound, if LEVO form, will gives dextro form, or dextro form will gives LEVO form. Whereas in SN1 mechanism, same isomerism may exhibit by the product, or the product may be a racemic mixture, or it may, that means it may retain the optical activity, or a racemic mixture may form. Whereas in SN2 mechanism, compulsory a new isomer will form due to SN2 mechanism. Important question is ambident nucleophile. Nucleophile means negatively charged species. That means which affect the nucleus. Nucleus is a positively charged species. So which species will attract the positively species? Naturally negatively charged species. So negatively charged species is said to be a nucleophile. In substitution reactions, this negatively charged species will attack the nucleophile. So here certain nucleophiles are there. They can attack from both sides of its ends. For example, if you take cyanide Cn minus, if the Cn minus will attach the nucleophile like this compound is said to be cyanide, or if it attack like this is said to be isocyanide. So this nucleophile can attack the nucleus of the attacking atom from carbon side or from nitrogen side. This type of nucleophiles are called as ambident nucleophiles. For example, if you take OH minus always attack from oxygen side only. It cannot attack or attach to the nucleus with hydrogen side. But some nucleophiles are there. They can attach from either from this side or that side. Similarly, NO2. This is also, it can attach from like this or it can attack like this also. Thiocyanide, SCN. This is also another examples of ambident nucleophiles.